Okay, we're talking about the empirical rule, and the empirical rule only applies to mound-shaped distributions. Consider the Hershey Kisses that you're working with in Lab 1. Hopefully you've seen in creating a histogram that those are in a mound-shaped type of distribution. And what we want to do is to see what the empirical rule is saying about mound-shaped distributions. Now, the first thing it says is that approximately, and a key word here is approximately, 68% of the values in a data set that is or has a mound-shaped distribution. In other words, its histogram is symmetric, centered around a particular value. Similar to the sketch I've made here. 68% of the values in a data set will be within one standard deviation of the mean. So let's say that the Hershey Kisses average turns out to be 4.6 grams. And we'll just say for making the calculations easy here, suppose that the standard deviation was 0.2 grams. Now, what the empirical rule is saying is that in a mound-shaped distribution where the average would be pretty much in the center of that if I go one standard deviation to the left, so that would take me down to 4.4, and one standard deviation to the right, which would take me up to 4.8, that approximately 68% of the Hershey Kisses in that data set, 68% of them, will be in that range. And again, I emphasize the word approximately. Approximately 68% will fall within one standard deviation of the mean, which in this particular case would be somewhere between 4.4 grams and 4.8 grams. Now notice something else here. 68% would be within one standard deviation. How many would be less than 4.4 grams? How many or what percent of Hershey Kisses would be below 4.4 grams? And if you think about it, this is a symmetric distribution, a mound-shaped distribution. We've got 68% in the middle. So outside of 68% would be 32%. In other words, all of the kisses in the bag would be 100% of them. 68% in the middle, 32% outside of that. The distribution is symmetric, so that would be 16% on the lower end, and then 16% on the upper end. So what percent of the Hershey Kisses would be below 4.4 grams? There'd be 16%. Likewise, what percent of the Hershey Kisses would fall above 4.8 grams? And that would be 16%, with 68% in the middle. The empirical rule also says that approximately 95% of the values in a data set will be within two standard deviations of the mean. So again, looking at the Hershey Kisses here as an example with 4.6 in the center, I would go out one standard deviation, and that would take me from 4.4 then to 4.8. Approximately 68% is within one standard deviation. and then go out another standard deviation, which would take me down to 4.2 and then all the way up to 5 grams. According to the empirical rule, approximately 95% of the data in a data set that's mound-shaped will be within 2 standard deviations. So quite a large percentage of the data will fall within 2 standard deviations. In this case, 95% of the Hershey Kisses in the bag would fall anywhere from 4.2 grams all the way up to 5 grams. And then we could also make the argument what percent of the Kisses in the bag would be below 4.2 grams or above 5 grams. Well, we know that 95%, approximately 95%, are within 2 standard deviations, so the percentage outside of that would be 5%. And because the distribution is symmetric, in other words, one side's a mere reflection of the other, there would be 2.5% on the upper end and 2.5% on the lower end. So what percentage of the Hershey Kisses would be less than 4.2 grams? 2.5%. What percentage of the Hershey Kisses would be greater than 5 grams? 2.5%. The empirical rule says that almost all of the data is within 3 standard deviations. If the distribution is mound-shaped, almost 100% of the data will be within 3 standard deviations. And the book defines any data value that is beyond 3 standard deviations of the mean, either on the top end or the bottom end, to be an outlier.